All right, well, let's finish up 5.7 and even begin 5.8, I hope. We'll see. So let's finish 5.7, the financial ones. Tanisha, $1,000 to invest at 5% per annum, compounded semi-annually. How long will it be before she has $1,300? So remember, we had two formulas in this financial section. One of them is A equals P1 plus R over N to the NT. And the other one is A equals PERT. Right? Remember the two formulas? How do you know which one to use?
The one says
continuous or not, right? So this one actually has two parts to it, this question. This first part here does not say continuous. So this is the one we're going to use when it does not say continuous. It's not continuous compounding. The PERT one is when they say continuous compounding, right? All right, so use that first one on the left there and see if you can answer the question. I'm going to run through roll while you do. Okay, so so use this formula. Did y'all solve this okay? So this is a little tricky. So what do you do with 1,000? Where's the 1,000 go? What letter is the 1,000?
P.
That's the principal, because that's always what they put in first. Principal is always the money put in first. Okay, the 6% or 5%, I mean, is the rate, the 0.05. I think you know that. What's the N? Yes, semi-annually is twice a year. Remember, N is the number of compoundings per year. Semi-annually is twice a year. So 2, 2. And the T, I don't know the T. In fact, that's what they're asking me for. How long? So I'm trying to find T. I don't know T. So, and then what about the A? What's the 1,300? That's the A, isn't it? Because that's the amount. That's the goal. That's what we want to have in the end. Does that make sense on all those plug-ins? So there's my equation, and I'm trying to solve it for T. What do you think? How are we going to solve that for T? Yeah, because Hitler's climbed in the power, right? The letter has climbed into the power zone. When the letter climbs into power, the letter, not just a number up there, but a letter in power, that's going to be ln of both sides, right? I just do all that history stuff so you remember when you see it. Okay, so but first, before, I'm not quite ready for the ln right now. What do I have to do first? Get that 1,000, yeah, because you got to get the base alone first. Let me write that. So, well, get rid of this. So, again, letter, any letter in the power zone. That'll be big on this next test. Anytime, just remember, anytime the letter's in the power zone, you get the base alone, and you not second power. I'm getting confused. I got to stay focused here. L in both sides. L in both sides and bring the power down. All right. So first divide off that 1,000. Divide off that 1,000. That's just 13 then. Is 1 plus 0.05 over 2 to the 2t. And then you L in both sides. And the whole power is dethroned, comes out of power, comes down to the base level. That's the big, very helpful step. So ln 13 is 2t ln 1 plus 0.05 over 2. Everybody good to there? Once you get that letter out of power, it's not hard to solve. It's way, way easier, right? So I'll just bring it over here, and we're just really one step away because the T is out of power now. Yeah, so now we can just divide, right? Because now it's just on the base level. It's no big deal. It's just all times, right? It's 2 times the T times the ln. It's just multiplication. Just divide it. It's out of there. No big deal at all. Whatever and the 2 is gone. The whole ln's gone. T's alone. Whatever you do to one side, no choice. Do the same thing to the other. And that's just all type the buttons. Type it in your calculator. Hit the buttons, and you'll have T. Is that good? Somebody have that? I can get it too. Make sure you can get these with your calculator. What it is? There's my ln. There it is. ln 13 divided by. Remember when you type in your calculator, you got to put parentheses around the whole denominator, not the numerator, because it's only got one thing. But whenever there's more than one thing, in the top or bottom, you got to parenthesize that, or the calculator will be confused. So put parentheses around the whole extra set of parentheses around the whole denominator. Why? Because there's two things. There's a 2, and then there's an ln. Two things. It won't know they're both in the denominator unless you tell it with the extra set of parentheses. Unless you have one of those nicer ones that just already make it vertical. All right, yeah, I'm getting. Wait, did I do that right? What if I were 2? Yeah, I got 51.93. Is that what you guys have? Yeah? It's a lot of years. T. Does that seem reasonable?
Well, I'm going to say the...
No, that's too many years.
13, I get 1.3. For the 1,300 divided by 1,000. I get 1.3.
That's a long time.
1.3, not 13.
Yeah, that doesn't seem right, does it?
1.3, not 13.
What's that?
I think it's
Oh,
1.3
you're
and
right.
not 13.
Thank you, Taryn. Yes. This is 1.3. You guys should have said something a long time ago. You guys just let me go on and on with these crazy things. No, correct me. Yeah, 1.3. That's the problem. Thank you. It's 1.3, not 13. I should have seen that. 1.3. Yeah, it's 1.3.
13 over...
Just use your calculator. 1,300 divided by 1,000.
No, can you explain why it's 1.3 and not 13?
Yeah, because, well, 1,000 times 1.3 is 1,300. I don't know what else to say. It's not 13,000. That's what I was thinking. It's not 13,000 over 1,000. It's just 1,000. So yeah. So that was my wrong thinking. Yeah. So so it's 5.193. Is that right? No, not yet. I'm still doing it wrong. Let me redo it. I'm trying to cut too many corners here. All right. 1.3 divided by. Yeah, this calculator stuff's getting me too. 1 plus. All right, I'm getting 5.31. That seems reasonable. 50 years was a little hard to believe for only $300 growth there. But how many decimal places they want? 2 decimal places. 5.31 years. All right, good. Yeah, Sars.
What did you put in the calculator to get that answer?
Yeah, so ln of 1.3 divide by parentheses and then this stuff.
Oh, okay, the equal T.
Yeah.
Okay.
Yeah, come grab me after, and if you have trouble with the calculator. Anybody having trouble with the calculator, take 10 seconds. Because it's a little different in each calculator. I need to see what you're doing, and I can help. Other general questions on that? Letter and power, ln both sides, right? First get the base alone, ln both sides. Part 2, let's do part 2. Part 2, they say, well, I probably don't have time for this. Probably going to use up too much time. All right, part 2, same question. They say, if it's continuous, well, that means you use the PERT formula now, right? Now we do the PERT formula instead of the other formula. So part 2, same question, now with the PERT formula, because now they're saying, all right, now that compounding's continuous, can you answer again? Well, okay, the rest is the same. 1,300, and the principal's 1,000. The rate is still 0.05. It's just now the PERT formula because it's continuous. All the rest is the same. I'm just going to do it quick. Divide by the 1,000, get the base alone. That's 1.3, not 13. Get to there. You know the deal, letters and power. So ln both sides. The power is dethroned. ln 1.3 is 0.05t. ln e. ln e is just 1, huh? This is even easier. The PERT form is even easier, isn't it? Come up here, and we say, okay, so that's ln 1.3 is 0.05t. Last step, divide by the 0.05. And you'll get, it should be a little shorter time, because that's not much, but a little shorter time, because that's a little faster interest. So it should be 5.24. What was the last answer? 5.3 something? Wasn't it? Yeah, 5.3, so it's a little shorter. That's right. There we, 247, so it rounds to 5.25, I guess, if they want 2 decimal places. Yeah. There we go. Good on those two? Letter and power, ln both sides, once you get the base alone. All right, I'm going to move on. All right, Survey estimates the current average cost of college to be $32,309 per year. If the average cost of college increases 5.7% each year, what will be the average cost of college 12 years from now? So, inflation, it's just basically these same equations we've been using. Same equations. But inflation, 5.7% each year. Yeah, so that's annual. Yeah, that's compounding one time a year. Yeah, so when they say each year, that's compounding, right, one time per year. N equals 1. Compounding one time per year, N equals 1. So I'm going to use the same formula we've been using, P 1 plus R over N to the NT. The principal is the amount now, starting at the 32,309. They're basically saying this 32,000 number will grow 5.7% each year. It'll become what in 12 years? So I go, okay, the rate, the R is 5.7%, which is 0.057. N is once per year, 12 years. Is that good? College costs are rising faster than inflation. They have been for more than 10 years. I don't know if you think about these things, but I'm a dad with 5 kids. This crosses my mind quite a bit, having just dropped off one of my children at an expensive college. So I'm feeling it. This is true. This problem is true. It's expensive. 32,309. So let's see, 1 plus 0.057 to the 12th. So I'm getting an outrageous number, 62,838. It rounds to 15.
That's a tough student loan.
That's the average cost per year of college in 12 years if inflation continues at 5.7%. So that like almost doubled, huh? At that kind of rate. Yeah. It's been for more than a decade now. College costs have risen like double inflation. There we go. Is that good? And now, they got to do part B, huh? All right. So that makes sense. So any kind of inflation problem, you just make it a compounding once per year. Everybody getting the point of that? And you can calculate any kind of inflation, same formula, just compounding once per year. And then part B, if the savings plan offers a rate of 4.4% compounded continuously, how much should be put in the plan now to pay for 1 year of college 12 years from now? There's a rate of 4% compounded continuously. How much should be put in the plan now to pay for 1 year of college 12 years from now? Okay, so how much will 1 year of college cost 12 years from now? Well, that's this answer. That's what we just figured out. That's the cost of a year of college 12 years from now. So they're saying, okay, you're going to do this savings plan thing. Well, we'll do it over here, part B over here. And 4.4% compounded continuously. So that's the PERT formula. So I'm going to use the PERT formula. And they're asking, how much should be put in the bank? Like, what's P? So that 12 years from now, it'll make this amount. This is the A. 62,838.15 is PERT. And the rate, what is the rate? The rate is the 4.044. I'm kind of running out of room here. Let me move it over here. So the amount again is 62,838.15. The principal is what we're trying to find. The rate is 0.044. Come on. And the time, 12 years from now. So everybody see what I did there? Is that okay? So in part B, so part A, they had me figure out how much college will cost in 12 years, 1 year of college. Then part B, they said, okay, now that you have that amount, what principal will become that amount? At continuous compounding, so PERT formula, at a rate of 0.044, 4.4% for 12 years, time 12 years from now. How much you need to put in the bank now, so that in 12 years it'll grow to become, you can pay for a year of college.
I could just put in a lot.
So we got to solve for P here. So just divide both sides by the E to the 0.044 times 12, E to the 0.044 times 12, boom, boom, like that. That good? Just hit the buttons on your calculator. Whatever that becomes. We okay with that? Questions on that? What is it? You got it?
I think so.
$319.99.
I don't think so. You only put $300 in the bank, it'll become 62,000 in 12 years.
5,011.
I think I did my math.
5,000 what?
I think it's 5,011.
That seems a little low too.
5011.10.
Oh, so it's 5011 point.
10 cents. I think.
So only put 5,000 in the bank?
I got 37,000.
Yeah, right. You always want to stay in reality with these things. It's so easy to hit a wrong button, right?
My 300.
I mean, it just is. I remember that too. You're just going fast on a test. Keep yourself in reality. Could we really put 5,000 in the bank for 12 years? It becomes 60. I mean, hey, show me where that investment is. I'm in, right? That can't be the answer, right? It's got to be. Yeah, the 37 sounds more reasonable. 37 what?
37,060.
060
Yeah.
point.
90 cents.
Do that 90 cents.
Yeah, don't miss those pennies. Yeah, that looks a little more reasonable. I used to run the numbers twice when I took tests. I would do, I'd be hitting the buttons fast, and then I would just do them twice. Whenever I had a calculator intensive or several things like this test will be, I would just run them twice. And if I get the same answer twice in a row, it was very unlikely that I'd done something wrong.
Can we put that math Excel?
Oh, sure. 37,069. Totally. It's just straight ahead. All right. Yeah. So again, it's just inflation. Inflation, all these formulas are just growth. That's all inflation is compound growth. And and it's 3.6. That means per year. So n equals 1. That's what when they give an inflation rate, they mean once a year. They mean all the costs have risen 3.6% for the year. That's what you're saying. So if that happens every year, 3.6, 3.6, 3.6, what will happen? So you do A is P, 1 plus R over N to the NT. So you're starting with the principal of $1,500, something that costs $1,500 today. What will it be worth in 4 years? So 0.036 is the rate, over N is 1 to the 1 times 4. I want to make sure we get this one right because these sometimes fool me. I don't want to mislead you. 1.0, what is it? 1.036 to the 4th. I'm getting 1727. Yeah, that looks reasonable. 95. 1727.95. 1720. It's not this one they messed up. It was a different one. They're just saying this one poorly. What they're saying, when they're saying this, they're saying how much will 1,500 purchase in 4 years? Well, that just saying that sentence that way is just not
Misleading.
well, and technically they're wrong to just how much will 1,500 purchase in 4 years? It'll purchase 1,500. I mean, they mean they mean in today's dollars. Well, you got to say that. If you're talking then and you don't clarify, it means then. So anyway, all right, I'll quit criticizing them. They're not careful on this one. So what they're meaning is they're meaning 15. You know what I mean? The value of money changes over time, right? As inflation goes up. So what they're meaning is $1,500 in 4 years from now money will purchase how much goods and services. You guys take economics. I think it's interesting and fun stuff. Goods and services in today's dollars. That's what they're meaning. They just said, how much will it purchase? Well, it'll purchase what it'll purchase. It's $1,500. They need to say in today's dollars if they want to be clear. That's what they're meaning. So they're meaning how much of today's goods will 1,500 purchase in 4 years? It'll purchase less, right? Because prices will go up. Does that make sense? If prices go up, then in 4 years, 1,500 will buy less than what 1,500 will buy now, right? So it'll buy what this amount will buy today. So anyway, I'm not going to put this on the test. How you do it real quick, it's the same formula we used. You just say, oh, the 1,500 is today, 1,500 is the future. That's the future. 1,500 is the future. And they want the P, they want today's dollars. That's the part they're not saying. So that's the formula right there. You don't have to do their 1 minus thing. 0.036 over n is 1 to the 1 times 4. All right, let's crank this out. Make sure it's right. 1,500 divided by, so you just divide by that, right? 0.036 to the 4th. No, that was wrong. 1,500, I mean. Let me try this again. I forgot the 1. Right, this, you're going to divide both sides here, right? By the 1.036 to the 4th, which is really just 1.036 to the 4th. Right, solve for it. Now, if this doesn't come out right, then this is the one they messed. Yeah, this is the one. No, they're wrong. The answer is really 1302.12. They are wrong. I remember looking this one up. I remember being really disturbed by it. Spent like 2 hours in my office. It was like last year. And I thought, no, I kept thinking it out, thinking, no, this is right what I'm doing. And then I thought, but it's crazy to contradict the book. You know, they wrote the book and everything.
That's perfect.
So then I went on a website. I went on an inflation website where you just like enter the numbers and they do the thing. And my number was right and theirs was wrong. So they're wrong. Skip this question. Don't worry about it. The real answer is 1302.12. They did something backwards on it.
So I just get it.
I don't want to talk about it. Come to office if you want to talk more about it. I don't want to waste any more time. Come to office. Yeah. What's that? You got it right. Yeah. That's not. That 1,200 answer is not right.
Yeah, no, I got it right.
Yeah, Sam, I got 13.
Yeah, I got it right, too.
Oh, really?
Yeah.
Yeah.
Well, why'd they tell me the answer was 1295.39?
Because they didn't add, they subtracted.
No, I mean they're telling me the answer is 12. Right? I mean that's their answer. I didn't type that in. That's what they are saying is the answer. And so you typed in 1302.12 and they took it? Is that what you're saying?
It was a different answer, but I got it right. Like, it was different.
And you did this kind of method?
No, I used their method.
Yeah. No. Okay, let me try to be more clear. Their method is wrong. I mean, they'll say you're right. They are technically wrong. And there's a truth here. There's not just my opinion, their opinion. There's real life inflation. And I remember reading there about a year ago, because I did the same thing in class. I messed it up, and I was like, what? I really thought I was thinking right. I used up like 15 minutes of class time. Don't want to do that anymore. And I went back to my office for 2 hours, and I fiddled around, and I looked up inflation stuff, and I fiddled around, and I was like, no. That little formula they're writing, I know what they want to write, what they want to say, is wrong-headed. They're thinking wrong about inflation. And I thought about it forever, and I got really confident, but I thought, no, let me check. Went on official inflation, like more than one, like 2 official inflation websites, where you just type in the number, they calculate it automatically. My number was right, theirs was wrong. And I was like, all right, I'm done. I'm not messing with this anymore. I should yank this out of the homework. I just forgot. I'm going to make myself a note to just get rid of this question. So forget about this one. I understand the number thing, but if you're interested in economics at all, come by my office. I'll be glad to tell you about it. But their method is wrong. They did something wrong. They weren't thinking right about the inflation thing. Enough said. Let me see. Okay, if the amount that 2,000 will purchase is only $1,750 after 5 years, if the amount 2,000 will purchase is only $1,750 after 5 years, what was the average inflation rate? Yeah. If the amount that 2,000 will purchase is only $1,750 after 5 years, what was the average inflation rate? Yeah. Let's just skip these guys. Yeah. Let me see what number 26 is. Is it inflation as well? Hello. Oh, am I on the wrong screen? Yeah. So skip. Let's skip 24. 25 and 26. I should cut those out of the assignment. So skip those. I can't, once it's started, I can't alter the assignment. So just skip 24, 25, and 26. Just leave them. It won't affect your homework at all. I mean, it'll say 90% or whatever, but don't worry about it. I'll figure it all out in the end. It will not harm you. So 24, 25, 26, just skip those. If I have time, I might make the comment later, but I need to have my act together in my office and come with one clear story to be more clear, and I don't have